Okay.
So we are going to study today. We start with the study of viruses. During the first hour, I'm going to introduce the meaning of virus, the structure, and viral infections. And in the second hour, the second part of the class, we will start studying the first family of viruses, herpes viruses, type 1, type 2, and type 3. So, what are viruses? What are viruses? This is not very clear. Viruses are genetic elements, so pieces of genetic information that cannot replicate independently. So, viruses, as you already know, because I repeat it many times, are obligate intracellular pathogens. They can only replicate, they can only live inside a host cell only. This host cell may be either a prokaryotic cell or an eukaryotic cell. Look, also prokaryotic cells. There are thousands of viruses that infect bacteria. Viruses need the host cell for everything. They need the host cell for all metabolic activities, including replication. We don't know if viruses are alive or not alive. We don't know, because we don't know exactly the meaning of being alive. I think it's better to say that they are not alive. They are just pieces of genetic information, and the only purpose of this genetic information is to replicate. They are very small. Viruses are very small pathogens. We can't observe them using the microscope. So, they need to do everything inside the host cell. They need to replicate inside the host cell. However, viruses may be also found outside the cells. So viruses have an extracellular form. This extracellular form is called the virion, or viral particle is the same, the virion. And what is the purpose of the virion? The purpose of the virion is to infect a host cell. So, when the virus is replicating inside the host cell, this replication may be either cytocidal or non-cytocidal. Notice this. Cyto means cell. Cidal means killing. So, when some viruses replicate inside the host cell is destroyed. This is called cytocidal. So, a cytocidal infection is when the host cell dies, is destroyed after replication. However, other viruses do not destroy the host cell. This is called non-cytocidal infection. Cytocidal, the host cell is killed. Non-cytocidal, the host cell is not destroyed. Okay, so we are going to study the shape, the structure of this virion, the structure of the viral particle. The virion. And we are going to mention three parts of the virion. The most important is the nucleic acid. The nucleic acid of the virion may be either DNA or RNA. It may be either double-stranded or single-stranded. It may be either linear or circular. And When the nucleic acid is single-stranded, it may have positive sense or negative sense. What is this? We say that the nucleic acid is single-stranded with positive sense when the nucleotide sequence half is the same as the messenger RNA that they transcribe. We say that the single-stranded has a negative sense when the nucleotide sequence is complementary to the messenger RNA that they transcribe. Do you want to explain this? Because I'm sure that they don't understand it, and I don't know how to do it. Positive and negative sense.
Cô giải thích cho các bạn nghe chỗ này một tí nghe. Tức là cái virus nó sẽ có cái cấu trúc genome là tùy theo từng loại. Một số loại virus nó sẽ có cái cấu trúc genome là DNA, một số loại virus sẽ có cấu trúc là RNA, không có dạng tồn tại song song giữa DNA và RNA giống như là tế bào vi khuẩn nha các bạn. Thì đối với những cái nhóm virus mà nó có DNA hoặc là RNA thì có thể là dạng sợi đôi, có nghĩa là mạch kép, hoặc là dạng sợi đơn. Thì đối với những trường hợp mà virus có DNA hoặc RNA sợi đơn thì nó sẽ có hai dạng như sau. Trong trường hợp là DNA, virus nào mà có DNA ở dạng sợi đơn là ghi là sợi đơn dương, thì các bạn nhớ là virus này nó sẽ có cái thông tin, các cái nucleotide của nó giống như cái cấu trúc của RNA thông tin. Có nghĩa là DNA này sẽ sử dụng làm mạch khuôn để tổng hợp nên một cái RNA, và cái RNA này sẽ là mạch khuôn để tổng hợp nên RNA thông tin. Các bạn hiểu được không? Hiểu được chỗ này không bạn? Tức là nếu như virus có DNA là sợi dương thì sợi dương này nó phải tổng hợp tạo ra một cái RNA, mà RNA này không phải là RNA thông tin, mà cái RNA này sẽ là cái RNA mạch khuôn để tổng hợp nên RNA thông tin. Vì chỉ có RNA thông tin mới thực hiện được quá trình dịch mã để tổng hợp nên protein của virus. Chỗ này các bạn hiểu được chưa? Rồi, nếu như cái DNA của virus là DNA sợi âm thì cái DNA sợi âm này nó sẽ dùng làm mạch khuôn để tổng hợp trực tiếp tạo ra cái RNA thông tin luôn, và từ đó sẽ thực hiện quá trình tổng hợp dịch mã để tổng hợp nên protein. Được chưa ạ? DNA sợi âm tổng hợp nên RNA thông tin, DNA sợi dương sẽ tổng hợp nên một mạch khuôn để tổng hợp nên RNA thông tin. Có nghĩa là DNA sợi dương thì nó sẽ qua một bước trung gian nữa để tạo ra RNA thông tin, còn DNA sợi âm thì nó sẽ ngay lập tức tổng hợp nên RNA thông tin. Trong trường hợp nếu như virus nó có cấu trúc là RNA thì nó sẽ chia ra làm RNA sợi dương và RNA sợi âm. Virus nào có RNA sợi dương thì RNA đó đóng vai trò là RNA thông tin luôn, và khi nó vào bên trong tế bào thì nó sẽ sử dụng ngay cái RNA sợi dương đó như là RNA thông tin để tổng hợp nên protein. Còn virus nào mà có RNA sợi âm thì RNA sợi âm đó sẽ được làm mạch khuôn để tổng hợp nên RNA thông tin, thực hiện quá trình dịch mã để tổng hợp protein. Được chưa bạn?
Rồi cô.
Yeah, right. Okay.
Okay, so nucleic acid, DNA, RNA, double-stranded, single-stranded, linear, or circular. And when it is single-stranded, it may be positive sense or negative sense. The nucleic acid, the genetic information, may be also segmented or non-segmented. We will explain this in detail next week. Segmented means that all the genetic information, the genome, that is the meaning, is splitted, divided into different molecules. However, non-segmented means that the whole genome is found in only one molecule. We will try to explain this in more detail next week. Second part of the virion, the capsid. What is the capsid? The capsid is surrounding the nucleic acid. Like a coat, protecting the nucleic acid. The capsid is made of proteins. The capsid is made of very small proteins called capsomers. I will show you later. This capsid may have different shapes, different symmetries. The most common are called helical or icosahedral. I will show you later. And others. The most common, helical or icosahedral. And there is another concept when the concept of nucleocapsid. Nucleocapsid is the capsid and the nucleic acid together. So this is another concept. So what is the capsid? The capsid is a coat of proteins that protects the nucleic acid. And finally, some viruses, not all, some viruses have an envelope. And what is the envelope? The envelope is made of phospholipids, is a piece of host cell membranes. So the envelope is not made by the virus. The envelope is a piece of a host cell membrane that the virus has taken. Some viruses have envelope, some viruses do not have envelope. So we have two types of viruses: enveloped viruses and non-enveloped viruses, with and without. Non-enveloped viruses are also called naked viruses. Enveloped viruses may also have proteins in this membrane. These proteins are glycoproteins inside this membrane, and these glycoproteins work as adhesins. Some viruses with envelope may have other proteins called matrix proteins, and these matrix proteins are bound, linked to the inner layer of the envelope. Remember, the envelope is a double membrane, it's a host cell membrane. So they have an outer layer and an inner layer. So as you can see, we have many new words today, many new concepts. So I hope that you have read the class at your house before listening the class, okay? So you already know the meaning. So we go back to the PowerPoint. This is the structure of the virion, the three parts. In red color, we have the nucleic acid. Around the nucleic acid, this is the capsid, made of proteins. These small proteins are called capsomers. And outside the capsid, some viruses have an envelope. This is the envelope, only some viruses. So look, as I told you, the capsid may have different shapes, different symmetries, helical or icosahedral. This picture, this is a helical capsid. What is that? It's like an spiral capsid. This is the nucleic acid. And this is the capsid made of capsomers that is protecting the nucleic acid. This is a helical capsid. This is the nucleic acid, and these are the capsomers. So the capsid is protecting the nucleic acid. This is an icosahedral capsid. The shape is different, the symmetry is different. Icosahedral. This is an icosahedron in mathematics, okay? It's like a football ball. This is an icosahedral capsid with this shape, okay? So helical capsids and icosahedral capsids are the most common capsids found in viruses. So remember, the envelope found in some viruses is not made by the virus. The envelope is made of host cell membranes. These cell membranes may be either the cell membrane or the endoplasmic reticulum or the Golgi. The last word that we are going to learn is the word tegument. What is the tegument? The tegument is the space between the nucleocapsid and the envelope. So the tegument is found in envelope viruses, space between the nucleocapsid and the envelope. How are viruses transmitted? Viruses are transmitted by the same routes, by the same mechanisms as bacteria. Inhalation, ingestion, contact, sexual contact, or transplacentally, the same. For viruses, inhalation is possibly the most common route of transmission, inhalation. Viruses sometimes may only cause a local disease with local replication. However, some viruses may travel to tissues that are very far from the initial infection. So they can travel through the blood. This is called viremia. They can travel through the lymphatic system, or they can travel through the neurons. Viruses bind host cells because they have specific adhesins, the same as bacteria. So viruses also have virulence factors. Adhesins are virulence factors. Viruses have specific adhesins that bind specific receptors in the host cells. When the host cells are infected by the virus, the appearance of the host cells is very strange. So it is possible to know that the host cell is infected because they appear very strange. This is called cytopathic effect. Cyto means cell, pathic means disease. So what is the cytopathic effect? The cytopathic effect is the strange appearance of the host cell when the host cell is infected by the virus. That's the cytopathic effect. So look, we are going to study in very simple words what happens when the virus infects the host cell. We have a video that you have watched already in your house. In this video, we are going to study the 6 steps of infection. From the first one, attachment, to the last one, the release. So look, we are going to open the video. Wait a moment. Wait. Because I have to open the video that I hope that you have already watched. So look, this is the viral infectious process from the first step to the last step. In this example, we have an enveloped virus. This is an enveloped virus. This is the nucleic acid, this is the capsid, and this is the envelope with glycoproteins. And these glycoproteins of the envelope will work as adhesins, and they will bind specific host cell receptors. So look. So these are the virions. Remember, the virions are the extracellular form of the virus. These are cells, host cells, that are going to become infected by the virion. So these cells have specific receptors in the cell membrane, and these specific receptors will bind the adhesins of the virion. This is the first step, attachment. This is attachment. Attachment is when the virion binds, when the adhesins of the virion binds the specific receptors of the host cell. First step, attachment. Second step, the nucleocapsid enters inside the cell. This is called penetration. Second step. Look, and now the capsid is lost. The capsid is removed. This is called uncoating. Next step, the virus starts replicating, so synthesis of the nucleic acid, and the virus starts making the proteins that they need. So in this step, the virus starts synthesizing everything they need, the nucleic acid and the capsid. Next step, to make the capsid, so assembly of the capsid. And the last step is release. So look, now you can see that the envelope is taken from the host cell. So the envelope is a piece of the cell membrane. The envelope is not made by the virus. The envelope is made by the host cell. So release. So this is the infectious process inside the host cell. So 6 steps: attachment, penetration, uncoating, synthesis of nucleic acids and proteins, assembly of the capsid, and release. We are going to focus now in the first step, in attachment. So wait a moment. Wait a moment, because I have to open the PowerPoint. So look. So we are here. So we are going to focus in the first step, in attachment and penetration, okay? So look, this is an example of a virus with envelope. This is the same as the video. This is the same as the video. So look, this is an envelope virus that enters inside the host cell by fusing with the cell membrane. This is the same. So the adhesins bind specific receptors, and both membranes are fused together. And finally, the nucleocapsid enters inside. This is the same example as we observed in the video. However, other viruses with envelope enter by endocytosis. You know endocytosis from cell biology. So the virus, the virion binds to the cell membrane, and the virus enters inside an endosome. So this virus has entered inside the cell by endocytosis. And finally, this is a non-enveloped virus. This is a naked virus. This virus can enter inside the host cell only by endocytosis. So the proteins of the capsid bind specific receptors in the host cell membrane, and the virus enters inside by endocytosis. Look, when the virus enters and starts replicating and producing new virions, you still don't suffer disease. You don't show any symptom. Symptoms may appear much later. So remember the concept of incubation period from the first class. What is the incubation period? The incubation period is the time between the entrance of the virus until symptoms start. So this is the same concept as for bacterial infections. Most viral infections are very short and acute. Most viral infections are very mild or even asymptomatic. For many viral infections, the symptoms are non-specific. That means fever, chills, headache, myalgia, or flu-like symptoms. So look, many different viral diseases show the same symptoms. These symptoms are non-specific. Many viruses are only found in humans. However, currently, many viruses from animals, so zoonosis, are infecting humans. For example, the new coronavirus. The new coronavirus is a zoonotic virus from animals that has infected humans. And now something very important. I'm going to try to explain in the whiteboard. So what happens when the virion infects the host cell? What are the outcomes after the host cell is infected? Three outcomes are possible in the host cell. The first one, after the host cell is infected, the host cell will die. The host cell is destroyed. So many virions are released outside. This is called lytic acute infection. So after an lytic acute infection, the host cell is destroyed. The host cell dies, and many virions are released outside. This is a lytic acute infection. However, sometimes the host cell is not destroyed. The host cell does not die. This is called persistent infection. Persistent viral infection. The host cell does not die. That is the name persistent. And we have two types of persistent infections. We have latent infections. And we have chronic viral infections. And what's the difference? Latent, you already know, because this is from the first class. You already know latency. What is a latent viral infection? A latent viral infection is a persistent infection, so the host cell does not die, but the virus is inactive. no replication of the virus, like sleeping. You already know the concept. However, during a chronic viral infection, the virus is active. The virus is replicating, but this replication is very slow. So the difference between chronic and latent is that during the chronic infection, the virus is replicating, but very slowly. During latent infections, the virus is not replicating. So, what's the difference between lytic infections and chronic infections? During lytic infections, the virus is replicating. The virus is replicating quickly. However, during chronic infections, the virus is also replicating, but very slowly. And another difference, during lytic infections, the host cell is destroyed. During chronic infections, the host cell is not destroyed. So persistent infections. And finally, we have another one. This one is also persistent, but a little bit different. So we study these outcomes separately. Oncogenic transformation. What is this? During the viral infection, the host cell becomes a cancer cell. So the host cell is not destroyed. Does not die. So it's a persistent infection. So look, oncogenic means that the host cell becomes a cancer cell. Onco means cancer. Genic means to produce. So some viruses cause cancer. This is very important. Look, some viruses cause cancer. Mostly 3. There are many, but the most important are 3. Hepatitis B. This is extremely important in Vietnam. Hepatitis B virus. Hepatitis C virus, also important in Vietnam. And papilloma viruses. These 3 viruses are the most important oncogenic viruses. The most important, but not the only ones. We have a lot. So this is oncogenic transformation. So we go back to the PowerPoint. So look, these are the outcomes. Acute lytic infection, the host cell is destroyed. Latent infection, the host cell is not destroyed. And the virus is inactive without replication. And finally, sorry, not finally, chronic infections, persistent infections where the virus is replicating but very slowly. And finally, oncogenic transformation, okay, cancer cells. Look, latent infections, like sleeping, inactive, sometimes may become active again and cause a lytic infection. This is called reactivation. These are the most important oncogenic viruses. The most important that you have to remember now, the most common are hepatitis B, hepatitis C, and papillomaviruses. This is an example of an acute infection. Acute lytic infection, for example, the common cold. So you become infected. So you suffer a disease for a few days. After a few days, you recover completely and the virus disappears forever. This is the typical example of an acute lytic infection. Example of a latent infection that we will study later. Look, you are infected here. You suffer a disease for a few days. After a few days, you recover, the disease disappears, but not the virus. The virus does not disappear. The virus becomes latent. The virus becomes inactive, usually forever. And one day, the virus reactivates again and causes a disease again. This is the typical example of a latent infection that reactivates later, varicella zoster. And this is a chronic infection, for example, hepatitis B. You become infected, you suffer the disease, and you don't recover. You may recover a little bit, but the virus does not disappear. The virus is still active. The virus is still replicating. This is a chronic infection. The virus is replicating, but very slowly. Okay, so look, before we continue, this is what is a virus. The virus is a piece of genetic information. That's a virus. And the only purpose of the virus is replicating. The only purpose is replicating. And what is the purpose of genetic information? To make proteins, okay? This is what you already know. This is what you already know about the flow of genetic information. From DNA, RNA is made. This process is called transcription. And from RNA, proteins are made. This is called translation. So the purpose of genetic information is to make proteins through two different processes, transcription and translation, okay? And DNA may become replicated. This is called replication. So this is what you already know about the flow of genetic information. You know replication, you know transcription, and you know translation. This is what you already know. However, some viruses are very strange and they can do something more. Look, as I told you before, the nucleic acid of some viruses is RNA. So some viruses can replicate the RNA. This is called replication. This is not possible for human cells. We cannot replicate RNA. It's impossible. We can only replicate DNA, but not RNA. Some viruses can replicate RNA. And something more. Some viruses can make DNA using RNA. Some viruses can make DNA from RNA. This is called transcription. But this is transcription in the opposite direction. This is reverse transcription. This is only possible for some viruses, very, very few. We can classify viruses depending if they are made of DNA or RNA. They have double-stranded or single-stranded. And if they have single-stranded, they may be positive sense or negative sense. This classification is called the Baltimore classification of viruses. The Baltimore classification of viruses classify viruses into 7 types. And this information that I show you in the slide is very complicated, but we can make it more simple. And we are going to make a table to make it more simple. So wait a minute, we go to the table. I have to open the table and I show you. Wait a moment. Look, so this is the Baltimore classification of viruses. We are going to classify viruses into 7 types, depending on 2 features, or 3, depending on the nucleic acid, DNA or RNA, and depending if this is double-stranded or single-stranded. So look, DNA viruses, double-stranded, are called type 1. DNA viruses, single-stranded, are called type 2. Remember, single-stranded may be either positive or negative. Type 2 is positive. Sometimes it may be negative, but very few times. So remember, type 2 is positive. So 1, 2, RNA viruses double-stranded are called type 3. RNA viruses single-stranded are called type 4, or type 5, or type 6. Type 4 has positive sense. Type 5 has negative sense. Type 6 has positive sense. But type 6 is a little bit different. So I am going to move it here. And where is type 7? Type 7 is here. Type 7 is DNA double-stranded. Type 7. But type 7 is strange. So I am going to move it here to the right side. So look, type 6 and type 7, this one and this one, they are special for something. And why are they special? Because type 6 and type 7 can perform reverse transcription. So they can make DNA using RNA as a template. They can perform reverse transcription. So this is the Baltimore classification of viruses. Is the same as this one. Wait. Oh, very much. Wait a moment, because I cannot move the ballpoint. Is the same as this one, okay? It's the same information. This is the table that I showed you before. So look, in this picture, I show you the size of microorganisms. Look how small they are. This is E. coli. E. coli is very small. Remember the first practice when we show you E. coli in the microscope. They are very small. So look, viruses. Viruses are extremely small. This number 5 is influenza virus, very small. The coronavirus is the same as this one. The size is the same. So it's impossible to observe these viruses using the optic microscope. Maybe only one. Maybe this one. This is a pox virus. Pox viruses are very large. Sometimes we can see them using the optic microscope, but very few times. So viruses cannot be observed using the optic microscope because they are very small. We can classify viruses in a different way as bacteria. Remember, when we classify bacteria, well, when we classify living organisms made of cells, we use many different taxa. Remember, domain, kingdom, class, order, family, domain, kingdom, phylum, class, order, family, genus, species, you remember a lot of taxa. However, when we classify viruses, we have to use different classification systems because viruses are not made of cells. So to classify viruses, we are going to use the Baltimore classification that I showed you before. We are going to use the family, the genus, and maybe the species. So the classification of viruses is much easier than the classification of bacteria. In this course of microbiology, we are going to classify viruses as DNA or RNA in two groups, DNA or RNA. We are going to start with the study of DNA viruses. DNA viruses may be classified either with envelope or without envelope. We are going to start with the study of envelope viruses. So, DNA viruses with envelope, we have 3. And all of them are double-stranded. The first one that we are going to study are herpes viruses. The second one, hepatna viruses. And the third one, pox viruses. All of them double-stranded. In the second hour, we will study herpes viruses. Okay, so DNA viruses without envelope, we have 2 groups, double-stranded and single-stranded. Single-stranded, we have only one, parvoviruses. Double-stranded, we have 3. Papilloma viruses, polyoma viruses, and adenoviruses. So these are the 7 types of DNA viruses that we are going to study. We are going to start with herpes viruses. By the way, look, all DNA viruses that infect humans, all are double-stranded, except one that is single-stranded, parvoviruses, okay? All DNA viruses that infect humans are double-stranded, except one. In the next class, we will study herpes viruses. So we are here, okay? And we are going to study DNA viruses. The first one, herpes viruses. The family, Herpesvididae. So before we continue with the second class, do you have any question about viruses?
Yes. Is there any situation where one virus can have many envelopes?
Yes, some viruses can have many envelopes. For example, pox viruses that we are not going to study because we don't have time. Pox viruses have several envelopes, sometimes 2, sometimes 3, sometimes 1. Yes, it's possible, but it's not common. The viruses, pox viruses are many, and the most important is variola major, that we don't have time to explain. They have several envelopes, yes.
Which one is more virulent, the envelope one or the non-envelope one?
Well, virulent, it depends. It does not depend on the envelope. But the envelope, for example, viruses without envelope are more resistant in the environment. Viruses with envelope are less resistant. But virulent we have in both groups, with envelope and without envelope. But resistant viruses are usually without envelope, more resistant in the environment. I mean, they are more difficult to clean. Viruses with envelope, for example, the new coronavirus has envelope. They are not very resistant in the environment. They are very easy to clean. However, viruses without envelope, for example, papillomaviruses and adenoviruses, they are very sensitive in the environment. They are very resistant in the environment. They are very difficult to clean because they don't have envelope. So without envelope, more resistant. Okay.
Thank you.
Yes. More questions? So we can stop for 5 minutes. Okay. Okay, so we stop for 5 minutes.
Các bạn có đó không? Alo.
Alo ạ. Alo ạ.
Này cô nói là tại vì là cái ngày thứ năm á mình sẽ nghỉ lịch lễ á, nên là thầy muốn là chúng ta học vào ngày thứ tư, tức là sáng thứ tư được không? Tại vì cô thấy lịch của các bạn là sáng thứ tư là bắt đầu từ 9 giờ đến 11 giờ, thì có thể là chúng ta học từ khoảng 7 giờ đến 9 giờ được không? Để
được.
vậy có
Được
gì
cô, được.
vậy thì cô sẽ xin một cái phòng và xếp lịch, sau đó cô sẽ gửi cái ID với lại badge qua cho các bạn, rồi chúng ta sẽ học vào sáng thứ tư nghe.
Dạ.
Và các bạn đọc trước cái bài số 11 là cái bài của ngày thứ năm á, nhưng mà vì thầy dạy lesson 11. Yeah. Bài số 11 nha các bạn, nên các bạn đọc bài trước rồi đến ngày đó thì thầy sẽ dạy từ bài số 11 để mà đồng đều giữa cái lớp của ngày thứ 6 nữa, được chưa?
Dạ.
Rồi, có gì cô sẽ gửi.
Dạ.
Ok. Rồi phần lý thuyết lúc nãy có gì thắc mắc không các bạn? Tiếng Việt.
Dạ chắc không.
Rõ ràng.
Rồi, ok.
Okay, so we continue with the class.
Yes.
Okay, before we continue, I forgot to tell you something before. I forgot to tell you, well, I sent you an email. But I didn't receive any reply, so I don't know if you received or not. So there was a mistake in the classes last week. There was a mistake, and you have to correct it. In the class, I told you something wrong. And we have to correct it. The size of droplets, remember droplets, the size is more than 5 micrometers. In the class, I was wrong, and I told you 0.5. Okay, no, it's 5. So please correct this from the classes last week, okay? Because that was wrong. Droplet size is more than 5 micrometers. I'm very sorry for this. That was my mistake. So we can correct. Okay. So we are going to continue with the class today. So we are going to start with the first one of the DNA viruses. When we study viruses, we are going to follow this table that you already have. Wait a moment, if I can see it. Can you see the table, please? Yes. This is the table, this is the picture that we are going to follow to study viruses. The clinically important viruses may be divided into 2 groups, DNA viruses and RNA viruses. We are going to start with DNA viruses, with envelope or without envelope. We start today with viruses with envelope. All of them are double-stranded. And we start with the first one, with herpes viruses, the family Herpes viridae. This is the place where we are. So we are here, the family Herpes viridae. The family Herpes viridae are 8 types, not only one, 8, a lot. And we are going to study all of them. Today, we are going to study type 1, type 2, and type 3. In the next class, we will continue with the others. They are double-stranded DNA, so type 1 of Baltimore, with linear nucleic acid, icosahedral capsid, and envelope. The only thing that you have to remember is that they have double-stranded DNA, okay? And we classify them inside the envelope viruses. This is the only thing you have to remember. 8 types of herpes viruses, 8 types, but we are going to say something common for all of them. So this is the family Herpes viridae. Remember that viridae means family of viruses, and they are 8 types. We call them human herpes virus, type 1, type 2, type 3, until type 8, 8 types. But they have some things in common. The first thing that they have in common, they have, all of them, a latent stage. So they cause latent infections. So for all of them, when we become infected, we suffer a primary disease for a few days. After that, they become latency, and sometimes they may reactivate. So they become active again, they wake up, reactivation, and cause disease again. All of them will follow this picture. Primary disease, latency, and reactivation, all the 8 types. The primary disease may be asymptomatic. This is usually found in children, or symptomatic. Symptomatic may be mild or severe. Mild, usually children. Severe, usually adults. This is about the primary disease. What about the reactivation disease? The reactivation disease may be also symptomatic or asymptomatic. The reactivation disease is usually found in adults. And the reactivation disease is usually, not always, opportunistic. Not always. So the reactivation disease usually appears when the immune system is failing. This is the first thing that we have to remember about herpes viruses. Second thing, so look, so for herpes viruses we have two diseases, the primary disease and the reactivation disease. These diseases, the primary disease and the reactivation disease, may be either the same disease or different diseases. I mean, they may appear with the same appearance in the body or different. Today we will study one case. Third feature, common for all. Herpes viral infections are lifelong. So, forever. When you are infected forever. Herpes viruses do not disappear from the body. They infect forever. It's very important. All of them are transmitted by close contact. All of them. Skin, mucosas. Some may be transmitted, some are transmitted by droplets, as you already know. Actually, droplets are a kind of close contact, or by sexual contact. Sexual contact is also close contact. And some of them transplacentally, but all of them by close contact. And fifth feature, all of them are found worldwide. They are ubiquitous. You already know the meaning of this word. Ubiquitous means that they are found everywhere. And their prevalence is similar in all countries, except human herpes virus type 8. For human herpes virus type 8, the prevalence differs depending on the country. So 5 features common for all herpes viruses. Now we can start with the first one. We are going to start with human herpes virus type 1 and human herpes virus type 2 because they are very similar. And later we will study type 3. To study herpes viruses, we are going to follow this picture. Sorry, I'm going to delete this because it's from the other class. Wait a moment. To study herpes viruses, we follow this picture. Okay? From exposure to disease. From exposure to infection, because everything is infection, and disease. Remember, primary disease, latency, and reactivation disease. We are going to try to follow this picture, okay? And we are going to try to follow the table that you have. Wait a moment, because I have to open the table. This is the table that you have with viruses. Because we are going to study a lot of information, we are going to follow this table, okay? Because it's easier. So look, before we start, we are going to fill this table. We study herpes simplex type, human herpes virus type 1 and type 2. Their common name is herpes simplex. Herpes simplex type 1 and herpes simplex type 2. Both type 1 and type 2 are called herpes simplex. Herpes simplex 1, herpes simplex 2. The host cell where they replicate, so the target host cell, are mucoepithelial cells. For both. And what about the most common diseases? The most common diseases for both of them are very similar. Orofacial diseases, so in the mouth and the face, orofacial, or genital. For both. However, for type 2, the genital diseases are more common. And for type 1, orofacial diseases are more common. Okay? So genital, mostly type 2. Orofacial, mostly type 1. These are the most common, but they can cause other diseases. For example, type 1 may cause encephalitis that is very severe. Or infections, well, this is the most important. And type 2 meningitis, that is also very severe, and many other diseases, okay? But these diseases are not so common. So remember, primary disease, latency, and reactivation. Both viruses, type 1, type 2, the site of latency are neurons. So they stay latent, inactive, like sleeping inside neurons, both. And the most common transmission is close contact for both, including sexual. Mostly type 2. Sexual is more important in type 2, okay? And we don't have any vaccine against them. And we are going to study now the same using the picture, okay? So we start here. We start with exposure, close contact, or sexual, okay? The primary disease. So when we become infected, we suffer the primary disease. Primary means first, for the first time. This is orofacial or sexual, the most common, okay? Latency inside the neurons. And the reactivation disease is the same, orofacial or sexual. What about the primary disease? These viruses are very common. For example, type 1 is found in about 90% of people. I will show you later the picture, okay? So most of you and me have become infected when we were small children. So we usually suffer an orofacial disease by herpes simplex type 1. This primary disease, orofacial, is called gingivostomatitis. Gingivo means the gums of the mouth. Stoma means mouth in Greek language. And itis means inflammation, infection. Gingivostomatitis. This is very common in children. I show you everything now. So look, herpes simplex viral infections are very common. Between 80 to 90% of people have been infected with type 1. 20–30% of people have been infected with type 2. Most of these infections are asymptomatic, usually in children. Remember, herpes infections are usually asymptomatic in children. So look, this is the orofacial disease. This is the disease in the mouth. This is the most common herpes disease in the humans, the orofacial disease. Look, this picture shows you the orofacial infection. This is called gingivostomatitis. The gingivostomatitis is found in the mouth and is very painful. Gingivostomatitis, the primary disease, appears for a few days. After a few days, it disappears and the virus becomes latent. The virus becomes latent inside the nerves. And sometimes the disease may reactivate. When the disease reactivates, it goes again to the mouth, but it's not so severe as the primary disease. So look, primary disease in the mouth for a few days. After that, the virus travels through the nerve. The virus travels through the nerve to the ganglion, and they stay latent in the ganglia. Latency. After that, reactivation. So the virus replicates and goes again to the skin. Reactivation disease. This is what happens. This is a primary disease. This is a gingivostomatitis in a child. Lesions in the mouth, very painful. The child is usually a baby, and the baby doesn't want to eat because it's very painful. This is the gingivostomatitis. Look, the lesions in the lips, in the tongue. However, this is the reactivation. The reactivation is found in the lips, only here or here. So this is not so severe. Reactivations are usually milder. So look, gingivostomatitis, painful lesions in the mouth, reactivation disease, only found in the lips, not severe. Some people, usually women, may suffer many reactivations in their life, a lot, sometimes many times every year. This is herpes simplex type 2. This is the primary disease in the genitals, painful, transmitted by sexual contact. This is in the skin of the chest, because it may appear in other places, not only the mouth. For example, in the fingers, but this is not so common. The most common primary disease is in the mouth. These diseases may be treated with antivirals. The treatment of antivirals is found in the self-learning topic. I don't remember which one, but one of the self-learning topics is related with antivirals. The most common antiviral that we use is acyclovir. This is the most common. But we only treat some, not all, only severe diseases. Okay, and to finish the class, we are going to study human herpes virus type 3. Human herpes virus type 3 is called varicella zoster virus. Varicella zoster virus. This is the common name. This is type 3. And the target host cells are also mucoepithelial cells and some T cells. And the most common diseases are these. The primary disease is called varicella, or chickenpox in English. but I don't like this name because it's confusing. And the reactivation disease is different to the primary disease. The reactivation disease is called zoster or zona. And in English, they call it shingles. But I don't like this word in English because it's confusing. So zoster or zona. So look, for herpes simplex viruses type 1 and type 2, the primary disease and the reactivation are the same. However, for varicella zoster virus, the primary disease and the reactivation are different. The site of latency is the same in neurons. And the most common transmission is through droplets, so respiratory route, but also through close contact. And for this virus, we have a vaccine. The vaccine is the Oka strain, is the name. So we go to the picture, and we are going to try to follow the picture. So we are going to do the same here, and we are going to follow the picture. For varicella zoster virus. So for varicella zoster virus, human herpes virus type 3, exposure through droplets or close contact. The primary disease is varicella. In English, they call it chickenpox. But I don't like this name because it's confusing with another one. So this is the primary disease. What is varicella? Varicella is a rash, very itchy, in the whole body that many children have suffered, most of you. Latency in the neurons. So after a few days, varicella disappears, the child recovers, but the virus does not disappear. The virus goes to the neurons and is latent inside the neurons. And some people, usually old people, because varicella is found in children, by the way, mostly children. So the primary disease is found in children, usually, and the reactivation disease is found in old people. Old people whose immune system is not working properly, they may suffer the reactivation. The reactivation is opportunistic, and the reactivation is called zoster or zona, same. In English, they call it shingles, but I don't like this word because it's confusing. Because herpes simplex type 1 or 2 are also called shingles, so I don't like it. It's better to use the scientific name, zoster or zona. And what is zoster? Zoster is also a rash, but not in the whole body. It's a rash found only in one dermatome. In the dermatome where the virus were latent. And this rash is not itchy. This rash is very painful. This is zoster. So look, the primary disease is a rash found in the whole body, very itchy in children. Zoster is also a rash, but not in the whole body. It's found in only one dermatome and very painful. I show you the pictures. So look, primary disease, varicella, chickenpox, in the whole body, itchy. After a few days, the child recovers. So the virus goes traveling through the nerve and stays latent in the ganglion, but only some. For many years, sometimes forever. In some patients very old, when the immune system is not working properly, mostly the T cells, the virus can start replicating in the nerve and go back to the skin and cause zoster. This is zoster. So zoster is not found in the whole body. Zoster is only found in one dermatome or two dermatomes. These are the dermatomes from anatomy that you already know. This is a child with varicella, chickenpox. This is the rash, the typical rash that we find in the skin. That maybe you remember when you were around 10 years old or 11. Very itchy in the skin. This is zoster. Zoster is only found in one dermatome or two dermatomes. Here. In one side or the other side. So unilateral, following one dermatome. This is zoster, very painful. This is zoster, following the dermatome. This is zoster, following the dermatome. Or this one, very painful again. Sometimes zoster may also appear in the face, following the dermatomes in the face. These are the dermatomes in the face. So this is an ophthalmic zoster, affecting the eye, the cornea. This patient also suffers keratitis that may be very severe. Or in the mandible, this is zoster. The mandible. So, should we treat these diseases? Should we treat? Only sometimes. For children with varicella, the treatment is not usually necessary. We only treat varicella in children older than 12 years because varicella is very mild in small children, but it may be very severe in older children. So the indications for treatment are adults, well, I mean, people older than 12 years, immunocompromised patients, or zoster. And the treatment is acyclovir or other antiviral drugs very similar to them. This is explained in the self-learning topic. We have a vaccine against varicella zoster. This vaccine is the Oka strain. This is a live vaccine. So remember from the self-learning topic, live vaccines cannot be given to pregnant women or to immunocompromised people. This vaccine is not perfect. This vaccine is found in Vietnam, but is not included in the program of Vietnam. This vaccine protects around 80% of patients. So 20% of patients are not protected and they can suffer varicella zoster. In these patients that are not protected by the vaccine but can suffer varicella, the disease is milder. This vaccine should be given in small children. But again, this vaccine is not perfect and cannot protect all the people. So let me go again to the pathogenesis, but we have some time and we can explain better. So look, for varicella zoster virus, almost all people have become infected. So more than 95% of people have been infected. So for sure you are infected, okay? So for sure, many of you remember when you suffer varicella. Maybe not all of you, because there is something very interesting in Asia, is that in Vietnam, not all children have become infected with varicella, not all, only some. In my country, for example, almost all children have become infected, but here, not so many. So maybe in Vietnam, I am not very sure if more than 95% of people, I don't know. Koha, do you know how many here? Do you know the prevalence in Vietnam of varicella? I know, I think it's lower than 95, but I don't know how many, because varicella is not so common here as in my country. Anyway, So please, the pathogenesis of varicella. When we are exposed, we suffer varicella in the whole body. This is a child, and the rash is found in the whole body, very itchy. After a few days, the virus travels through the nerves and stays latent in the ganglion of the bone marrow. Sorry, the bone marrow, of the spine, of the spinal cord, okay? And the virus stays latent here, and this latency, if the immune system is working well, this latency may be forever. In old people or immunocompromised people, the virus can reactivate later, replicate later, and go back to the skin and cause zoster in the skin. But zoster only appears in only one dermatome or two dermatomes, not in the whole body. I hope that you have studied already the concept of dermatome. I hope. That is from anatomy. It's very important. So zoster, only one dermatome or two dermatomes, and very painful. This is so painful that in some people, the virus zoster may damage the nerve, and the nerve may be damaged forever. And this is terrible because the pain is very terrible. But this is only possible in some people. Okay, so this is the pathogenesis of varicella zoster infection. So look, for varicella zoster, the primary disease and the reactivation disease are not the same. They are different. So when you suffer varicella, chickenpox, you only suffer varicella one time in your life, only once, because the reactivation disease is different. It's zoster. So when you suffer varicella, you are protected forever. You only suffer varicella once in your life. Okay, so before we finish the class, do you have any question?
Question?
Yes.
Is there a chance that if you don't you didn't experience the primary infection, but still got the reactivate?
For herpes simplex virus and for varicella zoster virus, it's possible that you only suffer the primary disease and never reactivates. Yes, that's possible, because their reactivation is opportunistic. So for many people, they only suffer the primary disease and never reactivates. That's possible, yes. But for herpes simplex type 1, reactivation is common in women. And for varicella zoster, this one that I show you on the screen, the reactivation appears in old people, but only in some of them, not all, okay? So yes, it's possible that latency is forever without reactivation. That's possible because reactivation is opportunistic.
So why there is a difference from primary and reactivate? Why are they so different?
Why are they so different? Well, the first difference is location. Okay, the first difference is location. When you suffer the primary disease, varicella, when you suffer the primary disease, you acquire the virus through droplets or through contact. So your immune system is going to produce antibodies. And these antibodies are going to protect you forever, okay? But antibodies cannot enter inside the nerves. They cannot enter inside the nerves. So when the virus reactivates later, the virus can only affect and cause disease in places where antibodies are not found. So the virus can only cause disease in the dermatome where the nerve, with the nerve affected. So if this virus in the nerve goes outside to the blood, the antibodies will neutralize it immediately. So in the beginning, you don't have antibodies to fight. So the virus affects the whole body. However, during latency and during zoster, antibodies are protecting you. But antibodies are protecting you only against varicella, not against zoster, because antibodies cannot enter inside the nerves. So the diseases are different, okay? The same is possible, the same is true for herpes simplex type 1 and type 2. The virus is only affecting some parts of the skin, not the whole skin, because your immune system is, the immune system has memory, and the immune system can fight efficiently during reactivation, okay? This is immunology, but we don't know immunology yet. More questions? Yes.
So the reactivation always weaker than the primary.
Sorry?
The reactivation is always weaker than the primary?
The reactivation is usually milder than the primary disease. Yes, usually, but not always. Sometimes the reactivation may be more severe. If, well, the general rule, we are talking here about the general rules. So the general rule is that the reactivation is milder than the primary disease. However, sometimes the reactivation may be much more severe, sometimes. I will tell you in the next class. When we talk, for example, about human herpes virus type 5, cytomegalovirus, you will know that the reactivation is much more severe. So the reactivation may be more severe if the immune system is not working at all. Okay?
Okay, thank you.
More questions?
Yes, excuse me.
Yes.
Why is the primary disease mild to children and severe to adults? Why the adults are supposed to be stronger than children?
Yes, that's a very good question. Because we go back to the first class. Remember that damage depends always on two things, on the microorganism and the host. The best way to fight viral infections is the cellular immune response, so T cells. T cells work much strongly in adults. So in adults, the T cell response is much stronger. So the disease is more severe because the T cell is stronger. So the damage depends on the immune system. In small children, the T cell response is not so strong. So they suffer the disease, yes, but it's milder. So the damage depends a lot on the T cell response. So
Okay,
the T cell response is good to fight the disease, but at the same time, it may cause more damage in some cases.
Okay, thank you.
This is also, we will study the same in the next class when we talk about human herpes virus type 4 and type 5, and when we study hepatitis B. The principle is the same. It depends on the T cell response.
Yeah, thank you.
More questions?
So this is some kind of super antigen in adults?
It's not related with superantigens. No, it's not related with superantigens. For herpes viruses, to my knowledge, this is not related with superantigens. No. Superantigen is an antigen that activates many different T cells at the same time. This is not the case. In the case of these infections, only specific T cells are activated, only specific T cells, but very strongly. It's a different case. More questions? No?
No.
Okay, so I remind you two things. We will continue because you don't have class on Thursday. We are going to teach the next lesson on Wednesday morning at 7, okay? And we are going to do it with another group. because we need a lot of time to teach because we don't have enough. So next Wednesday at 7 a.m. we have class, okay? And we will study the lesson 11. Second thing to remind you, second thing, the test. The test is already available in the Sakai platform. It is open until Sunday morning, okay? And what else? I think I don't forget anything. Yes. And correct the mistake in the class, okay? Correct the mistake about droplets that I told you before. Only that. Okay, so we will meet again on Wednesday morning at 7, and we will study the lesson 11, okay?
Okay. Goodbye.
Okay. Good luck and goodbye.